With the question, why tcVISION? tcVISION is a universal tool for data synchronization, for data replication to a new platform, for distribution over long distances, for migration from one platform to another, and as ideal addition to an ETL tool. Which challenges can be mastered with tcVISION? Often they are historically developed heterogeneous IT environments consisting of a mainframe and PCs with Linux, Unix, or Windows. Additionally, there are cloud systems or Hadoop clusters. Because of this, there's a broad variety of different data formats: relational databases, structured or unstructured datasets, and documents. Often the data is also in different character sets or stored with different procedures. So the task for our modern IT is to exchange data between different IT systems. tcVISION has different applications. Datasets with different data models on different platforms can be continuously synchronized and are available on every relevant platform. Real-time data can be provided for analytics, and tcVISION can also help with data or platform migration. The central premise is tcVISION moves data as little as possible, as much as necessary. This means that we focus on using as few CPU cycles as possible, and never transfer large volumes of uncompressed data in order to not completely use even narrow bandwidths. The tcVISION product philosophy is to put main focus on change data. We always use the most efficient way to read data and implement it on the target side. Especially for real-time data for analytics, it is very important to have as little latency as possible. Which sources and targets can be used with tcVISION? Of course, the traditional mainframe sources and databases on the distributed systems. On the mainframe, DB2, vSim, and also non-relational databases. Adabas, Datacom, IDMS, and DL1 can be processed and synchronized. On the distributed system side, we have the traditional databases, like DB2, Oracle, and MS SQL, but also newer ones like Postgres and Infomix. Adabas LUW is also a possible source or target. The synchronization can be performed from all these mainframe data sources to the distributed systems, and of course vice versa if the applications on the distributed systems become more important while the mainframe should also be maintained. Mainframe and distributed systems together can be a source for big data and cloud solutions. Different protocols can be used to synchronize data in cloud solutions or big data applications. tcVISION supports JSON and Afro, which is very useful for binary data. Also Google Protocol buffers or simply a CSV file. Kafka, HDFS, pipes, or JMS queues can be used as transport layer. It is important to note that the modular structure of tcVISION makes the implementation of additional protocols and transport layers very easy. To which platforms can the data be transferred? Of course to Microsoft Azure Cloud and Amazon Cloud, but own in-house solutions can also be used here. That's why the target systems were expanded, especially the MongoDB as document-oriented database becomes more and more important. For example, to migrate from the relational model on the mainframe to a document-oriented database. What does a tcVISION real-time replication look like? We start with the capture agent, in this case in a Z system. The data is read and sent to the server without processing. Transformation rules are in the repository. This means that the data is structured and then the transformation rules can be applied. The input and output data model can be completely different. The implementation to the target is performed by the apply agent, in this case a server on Windows, Linux, or Unix. Our receiver receives the data and implements it into the respective database. Of course, the most effective way of accessing those databases is used. Reverse replication can also be performed by a capture agent on a Windows, Linux, or Unix. The data is sent back to the mainframe and implemented into Datacom, Adabas, or DB2. This is controlled by two visual tools. The tcVISION dashboard is used for definitions and for managing the replication tasks. All administrative tasks can also be performed via batch or command line. tcVISION can be used for all kinds of data exchange in a heterogeneous environment. The data is captured, transformed, and implemented on the other side. This is also the case for the whole bandwidth of transmission, including the initial load and later the real-time transfer. tcVISION has an integrated repository containing all rules of transmission. A comfortable mapping function for the data structures makes it possible to connect different data models. There's a dashboard for managing the processes, and of course there's also performance monitoring. tcVISION avoids unnecessary CPU cycles on the mainframe. Backup, unload, or image copy data can be processed. This allows to transfer data very efficiently from one platform to another. What are the advantages? First and foremost, a cost reduction for data exchange. It is not necessary to move all data. Because of the focus on changed data, it is possible to move as little data as possible in little time. tcVISION can be used without any mainframe know-how, because all definitions are made on a graphic interface. There's no programming effort when defining complicated transformations. Additional middleware, message queues, or MQ series are not necessary. The data capture is always performed in the most efficient way depending on the respective database. tcVISION optimizes the transport of data, especially over long distances, in order to utilize the lines to their full potential. An excellent performance reduces latency. Thank you for your attention.